Welcome back to the Wiki tutorial video series. My name is Tom Albany with Biostat Global Consulting. In this video, we will give an overview of organ pipe plots. If the user requests it, Wiki generates one organ pipe plot per stratum for each weighted outcome. The plot allows an analyst to drill down and visualize cluster-level coverage in the sample. All organ pipe plots are organized in the same manner. Each cluster is represented with a vertical bar that shows the proportion of survey respondents in that cluster who had the outcome of interest. The vertical scale runs from 0 to 100%. The width of each bar is proportional to the sum of survey weights for respondents in that cluster. If the cluster represents 5% of the population in the stratum, then the bar will extend across 5% of the plot's width. If it represents 2% of the population in the stratum, it will extend across 2% of the plot's width. The shaded proportion of the plot corresponds to the weighted coverage estimates in the stratum. If the entire plot is shaded, the estimated coverage is 100%. If half of the plot is shaded, the estimated coverage is 50%. Clusters with highest sample coverage appear at the far left, and those with lower sample coverage appear at the right. This is what gives the plot the appearance of organ pipes in a concert hall. Organ pipe plots are used for two primary purposes. One, to visualize heterogeneity in cluster-level coverage, and two, to identify clusters with surprisingly low coverage. First, imagine that a country conducts a measles vaccination campaign, and the post-campaign survey estimates that only 50% of the eligible population was vaccinated. A natural question arises: which 50%? Was it 50% of respondents in all clusters? Was it 100% of respondents in 50% of the clusters and 0% in the other clusters? Was it a mix of clusters with high and low coverage? We can all agree that 50% coverage in a post-campaign survey is a disappointing outcome, but we cannot know what it means until we see how the cluster-level coverage varies in the sample. Second, these plots can help identify clusters with unexpectedly low, or even alarmingly low, coverage. Let's look at the plot showing proportion of children in District 20 who have received their first dose of measles-containing vaccine. We know from information not shown here that this survey used 30 clusters with a quota sample of 7 respondents per cluster. The survey used 30 clusters so that there are 30 columns. In this survey, every cluster represented the same proportion of the population, so the columns are all of equal width. 2 clusters found that all respondents had been vaccinated for measles. 8 clusters found slightly lower coverage. 7 clusters found fewer children vaccinated, and so on. At the right edge of the plot, we see one cluster with a very low proportion of vaccinated respondents, and one cluster where 0 respondents showed any evidence of having been vaccinated for measles. These data are from a simulated routine immunization survey. Depending on the vaccination goals of the country in question, different viewers may have different ideas about how high or how low coverage should be. We can probably all agree that 0% coverage is alarmingly low. We can also probably agree that some of the other lower cluster level coverage figures here are unexpectedly low. So this figure might cause us to wish to drill down even further to answer these additional questions. 1. Where are these clusters that are represented at the right side of this plot? What is their location? 2. Who is responsible for vaccination in those parts of the district? 3. Is there a reasonable explanation as to why so few survey respondents were vaccinated there? The next video in the series will show you how to identify the cluster IDs and cluster names that go with each column of the plot, as well as how to know what number of respondents is represented by each column. And a third video on organ pipe plots briefly describes 2 points of academic interest. Organ pipe plots have features in common with something called Pareto charts from the field of quality control. Also, the graphical display of cluster-level coverage is closely connected to something called the intercluster correlation coefficient, or ICC. The third organ pipe video briefly explores these connections. Wiki will make organ pipe plots if the user requests them with appropriate syntax in Block D of the control program. For the plots to be generated, the user must specify these two lines. The two Wiki globals, wiki_make_plots and wiki_make_op_plots must be set to 1 as shown here. After Wiki runs successfully, the plots will be found in the Wiki output folder named in Block B of the control program. The output folder will contain a subfolder named plots_OP. OP in this instance stands for organ pipe. Organ pipe plots have the string OP plot in their name. Finally, note that organ pipe plots are only interesting if the sample size in each cluster is more than a few respondents. When we use Wiki to analyze data from a DHS or mixed survey, we often do not create organ pipe plots because there are only 0 or 1 or 2 respondents aged 12 to 23 months in each cluster. If there is only one respondent, then cluster coverage can only be 0% or 100%. If there are 2 respondents, coverage can only be 0 or 50 or 100%. The figures are more interesting for surveys where there are, say, 5 or 7 or more respondents per cluster. Note also that some surveys have different numbers of respondents per cluster. Organ pipe plots are still informative in that situation, but, as the next video will show, they need to be interpreted with an accompanying table in hand that tells the viewer how many respondents were interviewed in each cluster. To sum up, organ pipe plots show the proportion of respondents in each cluster who had the outcome of interest. The shaded portion of the overall plot represents the weighted coverage estimate for the stratum. The plots are not especially illuminating if the number of respondents per cluster is very small, say 1 to 4. The plots are useful for determining whether coverage was surprisingly low in any of the survey clusters. If the viewer wants to identify which columns represent which clusters, then please watch the next video. If the viewer is interested in some academic connections between organ pipe plots and Pareto charts or intercluster correlation coefficients, watch the third video. If this video was helpful, leave a comment or question regarding it on its page on the Users Group website. See the link below. And if you haven't done so already, please join the Wiki Users Group at the TechNet21 website by also following the links below.